Welcome to the Edexcel Combined Science Chemistry Paper 1 revision video. In this unit, we're going to look at atomic structure and the periodic table, bonding, quantitative chemistry, chemical changes and energy changes. Every atom has a tiny central nucleus containing protons and neutrons. Protons have a positive charge and a relative mass of 1. Neutrons are neutral, also with a mass of 1. Electrons orbit the nucleus in the shells, so they're outside the nucleus. They're negative and they have almost no mass. The atomic number tells you how many protons there are, and the mass number is protons plus neutrons. Because the positive protons and the negative electrons balance, an atom overall is neutral. Exam questions often ask what is inside the nucleus, and you must answer only protons and neutrons. Electrons are never in the nucleus, they're always in the shells outside. Developing the atomic model. The atomic model has changed as new evidence has come in over the years. Dalton started with solid spheres. Thomson in 1897 gave us the plum pudding model, with electrons embedded in a positive ball. Rutherford's gold foil experiment showed something different, a tiny dense positive nucleus with mostly empty space around it. Bohr then placed electrons in fixed shells, and finally, in 1932, Chadwick added the neutron. If the question gives you data from an experiment, link the data to the conclusion. For Rutherford, most alpha particles went straight through, so the atom is mostly empty. A tiny number bounced back, so there must be a small, dense, positive nucleus. Electron arrangement. Electrons fill shells from the inside out. The first shell takes 2, the second takes 8, and the third takes another 8, so 2, 8, 8. We call that electronic configuration. So argon with 18 electrons has the arrangement 2, 8, 8. The number of electrons in the outer shell equals the group number, from 1 to 7. A full outer shell is stable, which is exactly why the noble gases in group 0 are so unreactive. When asked to draw or write an electron configuration, always use commas between the shells, like 2, 8, 1 for sodium. Examiners deduct marks for writing 281 as one number. Isotopes. Isotopes are atoms of the same element with the same number of protons but different numbers of neutrons. So they have the same atomic number but different mass numbers. Two examples, carbon-12 and carbon-14 both have 6 protons, but carbon-12 has 6 neutrons and carbon-14 has 8 neutrons. Isotopes have identical chemical properties because their electron arrangement is the same. Periodic table. The periodic table is arranged in order of atomic number. The vertical columns are groups. Elements in the same group have the same number of outer electrons and react in similar ways. The horizontal rows are called periods, where each row has one more electron shell than the last. Metals sit on the left, non-metals on the right. Group 1 are the alkali metals, and Group 7 are the halogens. Group 0 are those stable, noble gases that don't like to react with anything because they've got a full shell. If a question asks, why do elements in Group 1 all react in a similar way? The answer is always the same. They all have one electron in their outer shell. Same number of outer shell electrons gives similar reactions. Mendeleev. Mendeleev arranged the elements in 1869 in order of atomic weight, but he did something clever. He left gaps where the pattern broke, predicting that undiscovered elements would fill them later. He was right. We now arrange the table by atomic number, not by atomic weight, because that gives a tidier pattern with no exceptions. 2 marking points come up again and again. He left gaps for undiscovered elements and he predicted their properties. The modern order is by atomic number. Mendeleev guessed, Moseley measured. Mendeleev predicted, later work confirmed atomic number was the right ruler. Group 1 alkali metals. Group 1 metals all have 1 electron in their outer shell, so they react in similar ways. As you go down the group, reactivity increases, and that's because the outer electron is further from the nucleus and shielded by more shells, so it's easier to pluck or to lose that electron. With water, they fizz, produce hydrogen, and form an alkaline solution. Lithium gently, sodium quickly, potassium with a lilac flame. When asked why reactivity increases down group 1, the marking points are outer electron further from nucleus, more shielding, easier to lose. Halogens. Group 7 halogens all have 7 outer electrons and exist as diatomic molecules, Cl2, Br2, and I2. At room temperature, chlorine is a green gas. Bromine is an orange liquid, and iodine is a grey solid. Reactivity decreases down the group. It's the opposite of group 1. And this is because the outer shell is further from the nucleus, so it's harder to gain an electron. A more reactive halogen displaces a less reactive one from its salt. Group 0, the noble gases, sit on the far right of the periodic table. Helium, neon, argon, krypton, and xenon. They all have a full outer shell of electrons, which makes them very stable and unreactive. They're colourless gases at room temperature and exist as single atoms, not molecules. Going down the group, the boiling point increases because the atoms get larger. In the exam, the classic, why are group 0 elements unreactive? That question always wants the same wording, and it will be because they have a full outer shell of electrons. Remember, group 0 or group 0, or the noble gases as they're also called, has nothing to gain and nothing to lose. States and particle arrangement. In a solid, particles vibrate in fixed positions. In a liquid, they're close together, but they can move past each other. In a gas, they're far apart and move freely in all different directions. As you heat a substance, you give the particles more energy, so they break free of those fixed or closed positions and are able to change state. State changes do not change the particles themselves, only their arrangement and movement.